Hello and welcome to my video showcase. In this video I will talk about my project, the Iftach Custom-freeHA. Now, fryingyam is a program that is available on the internet. I did not create it. I simply modified it to work with Ubuntu. Now, this is very important to know. fryingyam is a high availability daemon. That is to say, it's a background activity that its main use is that of a cluster program. Now, let me explain what a cluster program is. For example, if I want a program, a function, anything, a site to run on one computer, and this computer suddenly stops, or the program dies, or for any other reason, and I want it to immediately begin or back up or something of the kin, I have another computer that listens to the activity of the first computer, and once the program stops or the computer dies, it begins the program itself, and this creates a sort of invisibility, which means that whoever uses this program, this computer, this service, is never actually aware that the service died on one computer and another one took over. This is very important for backing up services that are supposed to be ongoing. And this program itself is very easy to use. And today I'm going to explain. So why won't we begin? Well, first of all, I'm going to open the terminal. Very important to enter into root. Okay. Now, let me explain. I'm using the terminal because I want to show you how the program works. I want to show the output of the debugging. Normally, you can create your own startup daemon file, shell file, and simply double click it and the program should run. Now, since I want to show you how this works, we will be using the terminal. Now, a very important thing, the input, the only user input that this program needs is the IP of this node inside the network and the broadcast RP. Now let me explain this further. This is how I call the program. This is the exe file, and this, the -a, is my first input. Now, the first input I'm going to use, as you can see, is the internet address. It's the IP address of the network this cluster is running on. Now, basically, I want to enter, after this -a, the broadcast address. As you can see, this is the broadcast address. Now, since this broadcast address is a Class C network, you see here, let me show you the mask. It's Class C. This program automatically, if, for example, I choose not to input this, the program will automatically, on default, say, alright, you didn't specify, this is a Class C network. Well, since this is a Class C network anyway, we will ignore it for now. Well, for example, another important feature, I can enter another IP address. For example, if I had another node that also worked on this network, on this broadcast address, I could enter this here, and this would serve me as a backup. You see, for example, if I had two computers connected by a line and by a router, I could input the IP of the line and the IP of the router, and if one of them fails, the other would still work. This is a backup network feature. Now, it's important that you don't try to connect one computer through, for example, a private network and with a third computer over, for example, a router or the internet. Really, the creator of this program, of fryingyam, warned about trying this. I believe the program will go berserk. Unexpected things are going to happen, flying around. You don't want to know. Anyway, let's start the program. The first thing you can see is that it bound into various ports, and now it's entering the heartbeat loop. This is the loop where it looks for other nodes. It gives itself a bit of time to make sure that it really is the only one in the network. And as you can see, it immediately begins, starts all the initiating the code and running. Now, what it does here, this is a very important part. As you can see, it two things. One, the debugging. It constantly checks in a loop if this is main. This is important for later on, when we will begin with the other computer. For now, in this VM, as you can see, it knows only itself, and it checks. It enters the loop and asks, am I still main? Well, since it's the only one, it constantly enters the main loop. The other part is the echo of monitoring. As you can see, it constantly echoes monitoring. Now, if I'll then single this, you can see that it constantly goes into a loop. Well, since this is the entire thing, let me show you another interesting feature of fryingyam, at this point at least. As you can see, when we started the program, we have a text file called fryingyam inside the var/run folder. Now, this is important because I can now see the status of the daemon, of the computer. This is important because normally you won't be using the terminal. You'll be using a startup file, and you'll want to monitor the activity of the node. So here you have a constantly updating text file. You can see the seconds are running. This is very important. You get the computer, this computer, Ubuntu, the status, it's running, and the time. This is important for history and monitoring. For example, if you want to expand this later on, create a program that monitors the cluster itself, these are the files that you want to have access to. This is why it's very important to have permission in the root. You want to activate this program using root user. This is one of the reasons. Now, I believe this is everything for the first node. This is what the program does. But let's see, we only saw the lower part, the core of the cluster. Now, if I want to run things on it, for example, the echo of monitoring, how come this starts? Now, this is not from inside a code. This is from a service script. You see here, this is the installation folder. This is where I activate the make install, and it installs it inside the computer. Now, these are the three files I'm using. This is the shell file that is called when a program starts. This is the shell file that is now called constantly as the program is monitored. This is the file that is called when the program is